Hi everyone, this is Pankaj and welcome to the next video of solving most important DSA interview questions. So in today's video, we are going to solve another linked list problem and the problem statement is remove nth node from end of list, right? So in this problem, you are given with a head of a linked list and you have to basically remove nth node from the end of the list, right? And return its head. So let's understand this with a given example. So here you can see that initially you were given a linked list as 1, 2, 3, 4, 5, and we are also given the node number that we have to remove from the end. Please remember that we have to remove the node from the end, right? So we have to remove the second node from the end. So what is the second node? The second node is fourth node, and we have basically removed this fourth node and return the head of this linked list, right? So it's basically become 1, 2, 3, 5. Here you can say that if there is a single node and we also have to remove the single node from the end, so this is basically removing the head also. So here we remained with the empty linked list, right? So let's understand this question. So here I have taken the example, given example here. So you can say that we basically have to remove this node 4. That is, we have given that we have to remove the node from the end, that is number 2. So from the end, let's count here. Basically, this is number 1, this is 2, this is 3, this is 4, and this is fifth node, right? From the ending I am counting, right? So now you have to remove the second node from the end, right? So we have to remove the fourth node. So this question is pretty simple. You can see here that the basic approach that we can use is that what we do, we will come to the node we will come to the node 3 here, right? We will come to 3 from our beginning. We come to 3, and what we do, we will basically change the link of this node and put it here, right, towards 5. So what does it mean? That you basically remove the link from 4 to and added it to 5, right? So now what your linked list become is here 1, 2, 3. Then after 3, the serial node is coming out as 5, right? So this is the way you will apply your logic to solve this problem. Now you must be thinking that how we will come to this node, that is node 3. First of all, we will have to come to node 3, right? So to do that, we will have to traverse the linked list from the head only. So this is the head that is given, head node, right? So mark it as, let's mark head here. So this is your head node, right? So what you will do, first of all, you will traverse this linked list. You will come to 3, right? So how you will do that? So to do that, we will have to first count the number of nodes in the linked list, or you can say we will have to find the length of the linked list, right? And so what I am trying to say that let's say you find out, anyhow you find out the length of the linked list. So let's call the length as let's call it a length is equal to, what is the length? Length is basically 5, right? So you found that the length of this linked list is 5. Now you already had given with n is equal to 2, right? You can see here we were given with n is equal to 2. What does it basically mean? That from the ending you have to remove the second node. So you have to remove this second node. So to reach out to this node number 3, there is a formula that I want to share with you, that you basically, what you will do, you will have to reach out to the point 3. So how you will find this 3, right? So what you will do, you will basically do 5 minus 2, again minus 1. So what you are getting here, you are basically getting 2, right? So what does it mean? That you from the beginning you will have to traverse to the second node. Basically what does it mean? That from 0th node, that is let me write it down here. First of all, you will go to 0th node, then first node, then second node. So this is basically meaning that, right? So let me mark it as here. So this is basically mean that you will traverse from 0, 1 until 2, right? So basically it means that you will start your traversing your node count from I is equal to 0, then I is equal to 1, then I is equal to 2. Then you will reach to this third node, right? So when you reach out to this point, what you will do, you will basically change this pointer link from 4 to 5, right? So you will basically connect this two, right? So it will automatically get removed from the original linked list, right? And you must be thinking that but 4 is again is connected to 5, so we don't care about that because we have to return this linked list, right? So if anything is connected to this like this, right? Let's say here is a node, so it does not matter to us, right? Because again this is pointing to null, and we are returning the head. Basically it will return this linked list, right? So the major problem lies here is that how to find the length of the this linked list, right? So what you will do, you will first, so this is your head here, right? So you will first give, you will use another pointer. So basically, let me call it as, oh, okay, let me remove this first. So what I said that you will basically use another pointer, okay, and name it as a current pointer, right? Because you cannot move your head pointer. That's why you are using a current pointer. So what you will do, you will initialize your count variable. Let's say you basically initialize your count variable with 0, right? Now, what you will do, when you will, first of all, you will use a while loop until your current pointer is not pointing to null, right? So inside that while loop, what you will do, you will first increase the count pointer. Then what you will do, you will basically move your current pointer forward. So what you will do, current here will be current's next pointer, right? So until this point you will count the node count, all right? Now when your current pointer point to null, what you will do, you will basically come out of your loop, and at the end you will get your length of the linked list, right? So after finding that length, you will basically apply the logic that I have discussed here, right? Okay, so let's come to the code and let's see how we can code it out. So first of all, what I had said you that we will have to count the length of the linked list, right? So let's create in variable length is equal to, let's create another function to count this out, and let's pass the head here, right? Let's create this function solve. So now, first of all, you will have to initialize your counter pointer here, right? And you will have to check for the condition that if your head is already pointing to null. If it's already pointing to null, so what you will do, you will basically have to return 0. So what does it mean? That if your head is pointing to null, it means that there is no node containing any value, right? So if you are, if you want to see any example of it, so basically what does it mean? That there is a linked list with simply uh, no node value, and this, its name is head, and it's pointing to null. So what does it mean? Basically it's pointing to null. So this linked list does not contain any node, so its length is basically 0, right? So the same here we are coding, right? Now what I said that you will have to use your another pointer name as current, that will point to head only, right? And you will run your loop until your current pointer is not equal to null, right? So first of all, what you will do, you will first increase your count pointer, and then again you will move your current pointer to current next, right? At the end, you will be having your answer stored in your count variable. So basically, you will have to return count, right? So now inside this length, so this is basically the function to count the length of the linked list. Now this length variable will have your length of the linked list. Now what you will do, you will basically find the point where you have to reach. So here you can see that we actually found the length of this linked list, right? Now we have to find the point where we have to reach, right? So here in this case we have to reach to node 3. So how we had found that node? So basically what we had done is we had basically let's call it as to reach. We had basically find it out as length minus n minus 1, right? Now again what you will do, you will have to create uh, again a pointer. Let's again name it as current, that will point it out to head, because we cannot move our head pointer. Now after creating, so what you will have to check it out here, one point is that if your to reach, okay, let me write it as reach. If your to reach is less than 0, so what does it mean? If your to reach is less than 0, so here you can see understand with the example given here. So here what you had found that the length, okay, let me write it here. Here you had find that length is 1, right? And n is also 1. So to reach variable will store length minus n minus 1. So what it's equal to? It's basically equal to 1 minus 1 minus 1. So it's again equal to minus 1 at the end, right? So what does it mean? That if you are getting a negative value inside this to reach variable, what does it mean? It means that there you have to remove the head node only, right? Here you can see that we have to remove the head node, right? Okay, let's understand this with the given example. Okay, let's delete this. So let's say you are given with this node and this node, right? Let's connect them out. Now this is your head. This is your head, and you are given that you have to remove from ending n is equal to 2, right? It means that you have to basically remove this node, right? So to remove from our logic, we had got our length as length is equal to 2. Again we are given with n is equal to 2. So what you will do, to reach our to reach variable will store length minus n minus 1. So what it will equal to? It will basically equal to 2 minus 2 minus 1. So it's basically equal to minus 1. So what does it mean? That if you are getting less than 0, you have to remove the head node, right? And in this case what you will return? You will basically move your head pointer here, right? You will basically move your head pointer here and return this head. So it will return linked list from this point, right? So this is basically the logic here. So if your to reach variable is storing a negative value, so what you will do, you will basically move your head to we had make it as a current next, right? If this is not the case, then what you will do? You will basically let's create a variable I here. You will traverse till that point while I is less than to reach. So basically what you will do, you will basically move your current pointer to the next node, and you will basically increase your I. So after when you will reach that point, that is node 3, what you will do? You will basically have to delink the this you basically have to delink this link and point it out to the next pointer, right? So how you will do that? You will basically move your current next pointer to the current next, right? So you can see here that this is your current next and this is your current next, right? So this is very simple, and what you will have to return at the end, you will basically return head, right? So this is the solution of this problem. Let's try to run this out. So okay, there is a problem, RESCH, ACH, right? Okay, with null pointer to type of linked list node. So okay, we are basically not returning anything here. So we will have to return head here, right? We had moved our head. Now you can see that our public test cases are passing. Let's try to submit this problem. Okay, our solution beats 100% of the solution. So this was very easy problem, and if you had tried to solve this question by yourself, I must think you would have almost got your logic right. So this was all about in this video. So let's meet in the next video.